also be a function, f needs to be 1-to-1. Okay. So let me look at an example from the real numbers. Let me look at, say, f of x equals 2x plus 1, which is a function from the real numbers to the real numbers given by this straight line. As a matter of fact, we know what its graph looks like. Over here, where I represent the function f as a set of ordered pairs, ax, bx, and cz, if you draw this graph over here where the y-intercept is 1 and the slope is 2, this is what the graph of f of x equals 2x plus 1 looks like. Do you see that that is just a graphical representation of representing f as a set of ordered pairs? Right? Notice, choose any real number x, and you come down to this corresponding value of y. X, y is an ordered pair which lies on this graph, provided y equals 2x plus 1. So when you draw a graph like this, it's really an ordered pair representation of the function f. That's what the graph is. I've done before, but if you look at this, this is the rule for the function. F of x equals 2x plus 1. I could also write this as f of x equals 2x plus 1. What I would like to do is take this expression. This is an equation where the function is expressed as y as a function of x. And I'd like to solve for x as a function of y. I want to solve this equation for y. And we can write, solve this equation for x. And so I can subtract 1 from both sides to write this as y minus 1. And I can divide by 2 to write this as x equals 1/2 times y minus 1. Okay. By the way, if I look at this picture here, it roams throughout the domain, and y is assigned a value for x. When I begin with an expression of this type, y equals 2x plus 1, and solve for x, we're reversing the roles of x and y, which is true. But in general, we reserve x for what's called the independent variable. Hence, even though I solve for x in terms of y, if I want to write y inverse, I wouldn't write, or f inverse, I wouldn't write it as x equals 1/2 times y minus 1. It is the function, begin with the value in the domain, subtract 1, and then divide by 2. It doesn't really matter whether I call it x or y. Since this is virtually always used for the independent variable, and this one is used for the dependent variable, we rewrite f as f inverse of x, and f inverse of x is 1/2 times x minus 1. Right? It's a function, f inverse of x is a function which takes a value x in the domain, subtracts 1 and divides by 2, which is exactly what we did when we called it y.